like Carolyn said, first and foremost, I'd like to thank Carolyn for setting all this up. I'd like to thank everybody in attendance here today, as well as those joining us on the live stream. My name is Brian Whitaker. I'm a technical manager for ID Additives, responsible for the EcoPro line of products. I've been with the company for just shy of 5 years now, and this is what I'm responsible for. So today, I'm going to go through a little bit about what the chemical does, what I teach when I go on site to facilities about water cooling. I know that I have a mold here today, but everything that I'm explaining today also pertains to thermalators, TCUs, heat exchangers. If you're an extrusion, the heater bands, basically anything that's running water and experiencing scale. A lot of what I do is cleanouts because I want to treat the effects of water contamination and poor water quality. Beyond that, if you're somebody that has closed loop systems, the next step is to treat the cause, right? So if you have contaminants in your water, it's one thing to clean it out. It's another thing to prevent that stuff from coming back. So we have another product called EcoPro Coolex. It is a high performance coolant. And again, I usually try to get people on closed loop systems. That way you're not, you can recirculate that chemical and you're just eliminating the poor water. There will be questions and answers at the end, but if anybody here today has a specific question as I'm going through things, feel free to chime in. I might go through it slightly quickly. We do have a large library on YouTube that shows step-by-step instructions. So if you guys decide to bring one in, there's even an unboxing video and a lot of questions and answers on separate videos. So, and I would also state that if you guys go back to your shop and you decide to bring one in, you can watch those YouTube videos, but we are obviously set up here that I can do one-on-ones with you and your entire team. Should you want a little bit more interaction or something a little bit more private, I'm happy to do so. I do want to make note that I noticed that you guys probably see this cart here and some nice shiny gloss black ones up on the shelf. This is the second cart that we ever produced. She's been giving me a really good 5 years. So this is what I use as my demo. What I did not like was that the chemical went after the silver pigment. So we changed that to the gloss black. We did some testing on that. But I also have vinyl labeling on here, whereas these have laser engraved plaques. And then the only other change that we made, because I had some users that were wheeling a cart from facility to facility, is we put a Velcro strap on the front to prevent the drum from jockeying. You might notice other systems that are out on the market have a tank built into it. We opted for a drum because we realized the need that some people, they might not necessarily need 25 or 50 gallons of chemical. I've got some guys that micro mold and they get away with 5. Average users for the standard cart can get away with 10 to 15. We've got some XLs over here. Those go between 20 and 25. That pump is twice the size. So with that, again, I'm just going to kind of act as if I was in your shop teaching your tooling and your maintenance team. The cart runs off of compressed air. A lot of competition out there runs an electric pump. We opted for that for 2 main reasons. One being that every shop has air accessible throughout. So if you wanted to, for example, some heat exchangers, you didn't want to pull them off the press, you could wheel this right up to it. And there's probably shop air right there. But 2, and probably more importantly, and I will demonstrate this, is that an air diaphragm pump will actually sense pressure buildups. So it won't stop operating, but it'll pause operating. And it hits that point when it's 10 pounds less than your current air supply. So today I'm pushing 100 pounds. So let's say you had a tool that maybe you got in from a sister shop and you don't know what's going on the inside. And you hook up to it and it starts pumping, but then there's a blockage, maybe in a bubbler or what have you. The pump, when it would sense 90 pounds, would just say, hey, I've had enough, and it kind of pauses, which is fine. I want the chemical to eat away at the calcium, the silica, the manganese, all that stuff. Once flow is achieved again, the pump will kick back on. Whereas an electric pump doesn't have those sensors, or most don't have those sensors, and it's just going to keep hammering liquid until a line ruptures, and then you've got whatever acid that you're using all over the place. To that end, the acid that we use is phosphoric. That's the main active ingredient in it. It is the least caustic of the three main chemicals that you see on the market, which are hydrochloric and sulfuric. If you have a cart in your facility, it's more than likely a paperweight somewhere because nobody wants to put on the full PPE and get up and all of that stuff. So that's a little bit about that. I am going to turn the cart around just so you can kind of see what's going on. Right now, I have water in this tank. I guess that's a good point to make too. It looks pretty similar to the color of the chemical. I advise people to backflush with water when they're done for one main reason, and that is non-ferrous alloys within your tool. The most common one that I run into is beryllium copper. While the EcoPro chemical will not etch any metals, whether they're ferrous or non, if it's left behind on an aluminum surface or a polished surface or a beryllium copper insert, if it's not removed, it'll stain it just a little bit. So I just tell everybody, get in the habit of back flushing with water. Because what I don't want to have happen is you guys run production, pull the tool out, you flush it, close mold, and then throw it up on the shelf. And then when that customer calls again, you pull that mold off, you open it up. If you didn't notice a pinhole leak somewhere in there, you're going to be a little upset that there's a little bit of staining. So this is kind of the setup that I use. You can use the cart to back flush with water. But what I wanted to point out was that you can see that they're very similar colors. When you backflush with water using the system, you'll probably lose an ounce to 2 ounces of chemical, but the dye in it will make your water look almost identical. And I bring that up because I've had users say, your chemical's not working. Like, I don't understand. And then we go through troubleshooting, and then I realize that, hey, they had their water drum hooked up instead of the actual chemical. So with that, I'm going to hook up a flow meter. I carry 2 flow meters with me. One is from Berger and Brown. I have a digital flow meter as well as a pressure regulator, and that's because the cavitation of the pump is going to cause some pressure jumps. And I also have a Keon's clamp-on flow meter. I like the Berger and Browns if you have a dedicated water pressure testing station, or maybe you have a leak tester, because ultimately, what's the point of cleaning it out if you're not measuring how clean it is, right? With flow meters, you're allowed to capture GPMs, and you can do that. Most importantly, document it. You know, a lot of people, they just get a flow reading and they're like, perfect. But then production runs or it gets hung up on the shelf, comes back out and they're like, hey, Bob, like what was it last time? You're like, I have no idea. So at least write it down. I can't tell you how many shops I've been in and they don't document it. But I like these for that dedicated station. So in a perfect world, you bring your mold over to that station, you hook up your flow meter. Let's say you did half the mold and you read GPMs of like 6 GPMs maybe. Talk louder. Sorry. I feel like I'm yelling. For the oh, so John's back there. So if you're hooked up and you read 6 GPMs, maybe in an ideal world on that circuit, it's supposed to read 7. So you say, okay, I can gain an additional GPM. And again, that's going to go to what the cooling circuits are within your tool. I don't know the geometry on the inside. There's calculators online that you can say, this is the diameter of our circuits. This is the length. And you can plug in and it'll say, hey, the best you're ever going to get is 8 GPMs in this circuit. But the point of having this is that mold comes out of production. You hook it up to your flow meter with your constant flow of water. And if it's reading that high 8 GPMs, you say, okay, this time we can skip the descaling. But if it's 5.5 GPMs, you say, no, we've hit 8 before. Let's go ahead and hook up the descaling unit because I know that I can achieve better flow. It's important because as little as 30 thousandths of buildup can affect part cooling performance by as much as 60%. And traditionally what happens when I go into a shop, they take air, they shoot it through a mold, they feel it on the other side, and they're like, it's green light that mold. Whereas if you get an endoscopic camera, you can really scope it out. And I know you guys won't be able to see this, but you'll be able to see calcium, lime, all sorts of fun crud in there. But these are really nice. Oh, that one's a good one. I don't know if you guys can see that. These are nice to have just because if your tool room foreman comes in and says, yeah, I shot air through the mold and it green lights, you have this, I mean, that's way more than 30,000 buildup. This can definitely see a significant improvement. So when you're setting up a descaling unit, whether it's our system or somebody else's, these are nice to have as you're implementing your PM program. So if I scope this out and I document those and say this is mold 5820 and it looks like this, and then we find out that it takes 3 hours to clean the whole mold, the next mold that's starting into your PM program, you can scope it and say, hey, this looks worse than 5820. Maybe we dedicate 6 hours, right? You have your flow meters to take actual hard data, but you have this to kind of help guide you in the beginning, because that's really the number one question I get. How long until it works? How long until it's clean? Well, I don't know, because the geometry of all the circuits are different on every mold. So that's where this tool comes in handy. So I'm going to go ahead and hook up the mold. I'm going to do a few circuits. Any questions so far while I do this? You can. More often than not, when I get phone calls, it's people that no longer have any flow. And what you really want to do in that instance is isolate the circuits if you can, to really get it back down to bare alloy. So your initial cleanings do take the longest. But I have many users that after they've cleaned that mold initially, they've benchmarked, they've taken their readings, they know what each flow reading is on each circuit. The secondary and tertiary PMs, they can jump whole mold. So out 1 to N5, out 5 to N6, out 6, 2. We'll hook up our flow meter. The other nice things that I like about this Keyence clamp-on flow meter, and I have a power supply that's portable, but you can, they have a hardwired power supply. They've got a ton of fancy software on here that you can tie these into your software. You can set, and you'll see here in a second when we get some flow, you can set your variables. So if I knew that the first time I clean this, I hit 6.5 GPMs, I set my lower tolerance to 6.5. And then once it hits that, it turns green. So you're able to do other things in the shop. You don't have to sit here and actually babysit this. So the first thing that you want to do, that's my supply lance. This is my return lance. This is my supply line. This lance I'll tell you about in a second. This is my return line coming off of the mold. The chemical does break down with water. It's 85% water, 7% phosphoric acid, and the other 8% is the trade secret. So if you don't blow the mold out with water, eventually you'll dilute your chemical. So the first thing I tell people to do is blow out the mold. I did blow this one out this morning, so there shouldn't be very much water, but I still recommend pushing air first, one, because it's cheaper to lose air than it is any chemical that you're going to hook up to it. But then flushing with water to identify any leaks. So on the cart, and again, the new ones have laser engraved plaques that have indicators on which one. There's a 3-way valve on top with 2 one-way check valves. And I know you guys can't see it sitting down, but on the top of my cart, pump is set over to here and blowout is set over to here. So if I am plumbed into my blowout side and set to my pump, it's just not going to work because of those one-way check valves. So I always hook up to blowout air first. I turn to my blowout side and I turn on you can hear it kind of drumming up that water. I don't see any water coming out of the mold. So I'm safe to set over to my pump air side, swap my 3-way valve, and I slowly turn it on. And again, this is just water. I just want to make sure that those that are online and not here actually see the process of what I do when I first hook up a mold. We've got good flow, and when I actually change, I want to demonstrate that pressure block that I talked about, how the pump actually paused operating. So when I switch over to the chemical, I'm going to put on just this little makeshift three-way valve. So we've got good flow, don't see any water coming out. And I'm kind of getting ahead of myself a little bit, but when you're ready to shut this down, I lift up on the supply lance until my supply line runs clear. That way I know that the water on the internal lines of the pump are shut off. Move my air over to the blowout side. Again, back to that, turning that three-way valve. And I blow all the water back into the water drum. And this step can be achieved, like I mentioned before, if you have a dedicated leak testing station or a water pressure station, you can do this step at that time. And while I'm doing this, I know this little lance fell off to the side. There's a valve off to the side. So if you do run into a blockage, I usually tell people if the blockage doesn't break free in 2 hours, you want a way to relieve that pressure. That way you can disconnect the lines. And that's what that valve does. You make sure this short lance is back into your drum. You open the valve. That way the pressure comes back and returns the chemical back to the drum. And then you're safe. And I just tell people swap the lines from your in and out and hit that blockage from the backside. So with that, swap over to my chemical. Put my lances in here. Second while I do that. Now this is going to look a little funky, but bear with me because I'm trying to prove a point on the safety of the pump. So the mold's been flushed out with water, so I no longer need to blow it out. Now, I would also say here that if you're going to make any changes, instead of just immediately hooking back the chemical, like I just added this shut-off valve to demonstrate, I always recommend doing the same steps just to make sure whatever changes that you made on the mold don't have any leak spots or anything like that. I've seen it happen before. I've done it before. We had air come over to the pump side. That's leaking. And before I turn this on, I do need to make note of the filter housing unit. In order to keep your chemical at peak performance, we want to filter out all the contaminants that it's pulling out, right? The active ingredient in there wants to break down calcium, silica, manganese, fresh iron, not hardened iron. But that's what the filter's for. It wants to capture it before it gets back into the drum, because if it makes it back into the drum and it sits there, obviously that active ingredient wants to just keep attacking and eventually it'll lose effectiveness. My longest standing customer just hit the 4-year mark in February of using the exact same chemical. So I feel confident that I'll hit the 5-year mark, but I can personally speak to this chemical lasting at least 4 years. So it's important to keep it filtered. That's the consumable item on the cart. It's a 5-micron filter, but and again, there's plenty of YouTube videos on this as well. But the most common area that I have leaks is on the top of this filter housing unit, because it only moves this 90 degrees along the metal plate. And what'll happen is somebody comes over here and goes, oh, I need to bypass that. And instead, when they meet resistance, instead of turning the other way, they just torque it right off and they snap it right off. So instances where you would need to bypass the filter are in that blockage scenario, right? The filter can act as a blockage just like contaminants in the cooling lines can. So if you've been circulating chemical for an hour or two, and then all of a sudden you're like, it stopped, like what's going on? You come over here, you bypass your filter, and if you kick on, you know that filter's spent because it's collected a lot of contaminants. So just wanted to make quick note of that. So we'll set up over to our pump side, turn my three-way valve back over. I'm currently in filter mode, and we'll slowly turn it on. So once it returns, it'll be hitting my canister, my filter housing unit to fill up before it comes on my return side back into the drum. There it goes. Now, and I always preface this and why it's important to have a dedicated station, because if you're just using this cart to measure flow, I have a flow control valve on here, right? I could cheat, and if I take my reading now and then somebody shuts it off and comes back on. Sorry, thank you. You know, I can just increase the flow and kind of cheat that way. So that's why I do have some people that put a flow regulator on here. The downside to being at a warehouse, so my apologies. $11.25. I don't know how it sounds on the mic. The world's largest tank. Okay. So my flow meter here, again, I have a portable battery pack, and when we finish the Q&A, you guys are welcome to walk by. You can see that green light. The variable that's set on here is 5.3. It's reading 5.9 GPMs, and again, that's the one that you can change. So this would indicate that if you're walking around the shop, you see that green light, it hit that high tolerance that you set. But what I wanted to show while I'm over here is the safety of the pump by shutting off that valve. And the pump kind of just says, I've had enough, right? Which again is good if you wanted a blockage. I want the chemical on it. I want it to eat away at it. And then once flow is achieved and it's eaten it away, the pump continues. So it doesn't stop operating, it pauses operation. But more importantly, you're not building pressure anywhere else. You're not going to pop a line and lose any acid. So that's the majority of how this works. I would shut it down similar as I was doing water. So I'll talk a little bit more about different applications, then I'll open it up to Q&A. And then if everybody wants to come up and kind of check things out, see how it works. But I guess I should have started with this. When we first brought this chemical on board, I did a lot of surface application cleaning. Cleaning the backs of molds, cleaning platens, and we had a gentleman that came in and said, I'm putting your chemical through my pump. The problem is it's eating up my pump every 3 months. And he justified its effectiveness by buying 4 pumps a year. And the owner of our company walked out of the meeting and said, like, we're going to build that cart. So that's where the cart came about. But there are multiple uses. Supply side. And you guys are free to come up and do this as well. But you just apply a little bit on the back, and a little bit goes a long way. I usually let it sit on for 30 seconds to a minute. If it's really bad, maybe 2 minutes. Again, I'm going to do a small area so you guys can come up and do this. And I think I moved my paper towels, but you'll be able to see when you come up here just how quickly it knocks off rust. The benefit of doing that and cleaning your platens is the inhibitor that's left behind. It's a nano coating, so the next time you pull that mold off, you shouldn't have any rust on the backside. The flip side of that, again, it's water-based. Water dilutes it. So if you're in a non-climate controlled facility and you have mold sweat, eventually that water is going to break down that surface application inhibitor, and you might have to reapply. It's pretty much, now it's just a waiting game, right? To see how clean it is. So do I need a different mic? Good.
I actually have a question that came in through the Zoom. Does the chemical have any effect on rubber O-rings?
Thank you for that. So that was a $1 million question in the beginning. So what I did, one of our distributors, PCS, I ordered a bunch of different components. So I always preface this by saying, I understand there's different manufacturers, and I'm going to turn this down so everybody can hear me, and so that doesn't kick off. There are different manufacturers of everything, right? So one silicone O-ring might have just a slightly different, I don't know, ingredient component than another. So if you're uncertain about your specific O-rings, I always say get in a little aerosol cap, drop it in, check it after 1 week, check it after 2 weeks. But that being said, I've done testing and I actually thought these were 2021. These jars are 3/17/2020. So I've got neoprene, silicone, EPDM, Viton, PTFE. And what I expected to happen was that O-rings would swell up and dry rot. But they still hold their flexibility in this. I know you guys can't see it, but again, I'll allow everybody to come up here and see it. No ill side effects on O-rings. I mentioned the nor your rubber hoses. I thought those might dry rot a little bit. There's a little bit of coating on the end, but again, we're approaching 3 years of this stuff being fully submerged in it. I've done testing on all different alloys, and I will say coatings. This is a brass waterline spacing rod that's been fully submerged for almost 3 years. Or a bronze bushing, I think is what that is. So made it just a little bit shinier. But again, that's been submerged for 3 years. The only ill side effects I mentioned earlier, staining on non-ferrous alloys, would be any coatings. I haven't seen any coating that's withstood this chemical, and I typically run into armored step pins, nitrited ejector pins, things of that. Now, I'm not saying that if you're running through a mold and the chemical comes into contact that it's immediately just going to degrade that coating. The shortest life, I don't want to say to death, but the fastest I saw one of those strip was 4 days in complete submersion. So again, that's also why I tell people when you're done, get in the habit of back flushing with water. But also when you're done with the chemical, if you take it back to your station that's got that constant flow with a flow meter, you can benchmark your GPMs and document it, and that'll help save you down the long run, or down the road, excuse me. Also, and I'll pass these around, I do see, and I actually got a phone call earlier this week about a gentleman that said that my chemical ate away some of his aluminum, and I said it won't etch any alloys, but what can happen is this phenomenon, and you guys can pass that around if you want. I usually see it in these aluminum, these are manifold blocks. This one's a mod block versus just a straight tube side. What can happen is contaminants are in your water, right? Usually calcium will eat aluminum, and obviously thereby creating a void. And then the next contaminants that come through fill that void. So then it kind of acts like a Band-Aid. Well, this is designed to eat those contaminants. So what'll happen is if you flush through, it removes those and exposes these voids, and you could have a potential for a leak site. And that's what that block that they're passing around shows, just that. So anytime you're flushing an older tool, or if you want to go through a manifold, I just make users aware of that. If you're running brass or stainless, there's probably not any buildup whatsoever in there and you're fine. But I always say when you're first starting out and implementing a descaling program into your system, that start small, right? And understand the system, again, whether it's ours or somebody else's. Don't just jump the whole mold, because if you jump everything at once and maybe there's a component failure like that and you have a leak, now you've got to figure it out on 16 different lines versus an isolated circuit, or, one or two. So thank you for that question. Are there any other questions that have popped up on the?
Yeah, on Zoom, do we have any more questions, or in person? Please step up if you have any questions. We have a question right here.
So, I know there's a lot of factors that can impact it, but is there sort of a rule of thumb in terms of how long that inhibitor is going to be working or lasting?
Yeah, just conditions with inside your shop. And that's why I'm, climate controlled versus unclimate controlled. Oh, I'm sorry. The question was the effectiveness and I guess duration of the inhibitor when applied on a surface application. And again, it just has to deal with your elements, right? I've got some guys that clean their platens, they're in climate controlled and they don't, they do it once a year. So I'd say a year in climate controlled condition, but if you're, down in the Southeast region, you're going to have mold sweat significantly more than maybe somebody up in the Midwest that's, we can mold through the winter and stuff like that. So you might have to reapply a little bit more. Bill?
2 questions. Filter, is there any maintenance that needs to be done? Looks like that's sort of and the other question, if I mentioned it, what's the concentrate mixture again, ratio?
Yeah. So the questions for those online: concentrate mixture and any filter maintenance. It's 85% water, 7% phosphoric acid, 8% is the trade secret. So this does ship ready to use. You're free to dilute it with water if you want, because then you're just going to have to order more from me, which I won't ever say no to additional sales. But as far as filter maintenance goes, this is just the filter wrench to pop it off. You don't have to do filter maintenance, but I am glad that you raised that question, because maintenance on the cart itself, unless you, in the beginning, and why we changed to these laser engraved plaques on top and they indicate 90 degrees only, I'd have guys that would just snap this fitting off. That's been solved. But what I'm seeing is some of my users right around the 3-year mark. Is there any chalk white? You can kind of see the chalk white on the back of the cart. If you leave the chemical on for usually longer than 2 to 3 minutes, it turns this chalk white. It's not a big deal. It breaks down with water. Heat speeds up the reaction. So if you get a warm, wet rag, it'll clean off. But that same effect can happen, right? If you're familiar with an air diaphragm pump, in each of the manifolds, there are balls that kind of shift and let the chemical work its way through as like an open and shut. And if, let's say, we flush with this mold and then put the cart up for 3, 4, 5 months, what can happen is that same chalk white can build up just slightly enough that the ball inside the manifold of the pump sits on this PTF O-ring, and that it's just enough to make it stick just a little bit. And so then the users will pull out their cart and say it's not pumping. And that's the first thing that I have them do, is run hot water through their system. Water breaks it down. So if you know that you're not going to be using the cart for 3 to 4 months, just your maintenance is hot water to keep that pump clear. That's really the only maintenance I see. The pump itself is designed to last 3 million strokes, right? So a stroke counts as each cavitation of that pump. I have this open at about 20%. It can go a lot faster, right? You don't need velocity to clean out the tool, right? The magic's in the chemical. So the only thing that I'm doing by turning it full bore is shortening the lifespan of the pump. I mentioned 3 million strokes. In order to hit that, you would have to be running 100 pounds of pressure, wide open, 8 hours a day for 11 months straight. And then usually there's like a little gasket that's in the middle of the pump. Usually that's what goes first. I don't anticipate, I've done 2 pump rebuilds. And again, I've had carts out in the field for almost 4 years now. So I tell people to, from a budgeting standpoint, hey, maybe expect around year 3, you might need a pump rebuild. But as long as your maintenance team is purging water through it and you're not running full bore. Now, there are instances where, let's say we had a larger mold and it's on its second or third PM and we want to jump all the circuits, you might need the velocity just to get through the tool and really clean everything back out. But most guys aren't running wide open. So that was a long-winded answer to your filter maintenance question. Sorry.
So we had some questions come through Zoom. The first one is, what are the PPE requirements for surface applications? And the other one was, do you recommend getting a camera as a tool to show customers how the lines get clean with EcoPro?
Yes, I absolutely recommend a camera. If your shop doesn't have one, definitely invest in one. The one that I carry is a 5mm waterproof camera. It's got an 8 GB memory card. I've got 1,000 photos on this thing, video. More importantly, if you're not going to document the photo number that's on there, because it says, JPEG 0058, whatever. When I'm on the road and demoing, and if I hit 4 shops in a week, by the time I get back to my desk to upload, they all look the same. So at a bare minimum, what I tell people is with the camera, stand back, take a picture of the mold or the mold number, then scope your lines. That way, when you do get to a computer and upload it, you say, oh, this was mold 5820, and I know these are those circuits that way, because it'll happen. So it's definitely a valuable tool. And the other question was PPE for surface applications. My official answer is check with your safety committee. Obviously, a medical molder is going to have more strict standards when you're bringing in an acid. I also understand that people have different chemical sensitivities, right? It's very similar to mineral spirits. If you've ever had mineral spirits in an open wound, it gives like a tingling sensation. It's about half of that. And I do know that there are mineral spirit sensitivities. So I personally don't work with any specific PPE, usually other than glasses in case a line pops. I've ingested it. I've had it in my hair. I've had it in my eyes. I didn't have to do anything special. I wear contacts, but again, that's up to your shop safety committee when we give them the SDS. But it is, I'm sure I showed it earlier. For me, at least in my chemical sensitivities, it just kind of makes your hands a little bit sticky, but that's a good question. Flushing. That's why I try to have a flow meter hooked up if I can. Especially in the beginning stages of when you're PMing, because unless one of your engineers can tell you exactly the diameter of the line and the length of the line and saying, hey, this at its peak we're going to get 6 GPMs, unless you have that information, which most people don't. That's why I kind of use the flow meter in conjunction with the camera so I can scope that. So the issue is, and really what this solves a problem, is a lot of tools now have conformal cooling, right? All these little bubblers, like you're never going to get a camera in there. You're never going to be able to drill out in like conformal cooling sprue bushings or anything like that. So that's where you need to rely on the flow meter. Yeah. I do, yeah. And the reason why I use the Keonce when I'm on here again, I love my Burger and Brown, especially for testing. But what I found with this chemical, because I want to do it in real time, right? I used to have to hook up the water as I did in the beginning with my flow meter, with this flow meter, and then take the water off, put the chemical on, put the water back on, and this on. It's just because that same stickiness, and this is probably sheer laziness on my part. Instead of running hot water through this, there's a little bearing in here that sometimes it can kind of stick up a little bit, and then I have to take that out and recalibrate it. So the Keonce, it's taking an ultrasonic reading, so I don't have to worry about that. So, but I've got a lot of mileage out of this flow meter, and they're great. They're great tools to have. So it just kind of depends on how you want to set up your shop. My job is to kind of, and we don't sell these, by the way. I'm trying to help build a PM program and show you all the tools that I've used in the past and currently use as well. So, I think it read like 6.2. The tolerance was at 5.3, but in the beginning I said, I can cheat by just turning this. So what I'll do when we wrap up, I just didn't want that compressor to go off. I'll turn it on, I'll set it at a set point, and I'll benchmark what it is in the beginning, and I'll let it run for an hour as we're having lunch and do all that stuff, and we'll check it later on and see what it's doing. So in this particular instance, if I've jumped half the mold, right? So if I'm taking my readings there on half the mold, I need to document, hey, I did lines 1, 2, 5, and 6. So the next time it comes on the bench, if I'm reading 6 GPMs, but then another tech jumps lines 1 through 4, he's like, well, this isn't 6 GPMs. Well, it's not the same, make sure you're doing the same thing. That's probably the biggest, just document things, write it down in the notebook. If you don't have the software, if you have the software, even better. But
So we had a question come in. So other than the tool that we see here, what else can the Eco Pro cart flush out? Is it just tools or is there other things that can be flushed?
basically, if it's running water and experiencing scale and you can connect to it, this will clean it. I do a lot of heat exchangers, TCUs, thermalators, heater bands on extruders, feed sections on extruders. I mean, so much equipment. What I like about doing all these different pieces of equipment, maybe your thermalator is right at the press. If you know that thermalator and the copper lines plug up every 18 months, or your heat exchanger plugs up every 16 months, I tell people to, plumb in some shut-off valves with some quick connects right in line. So if it is every 18 months, then just say, hey, every 12 months, I'm gonna shut off my water supply, plug this in for an hour, let it circulate, keep it clean. You're not having your maintenance team spend the extra time pulling the heat exchanger off. You're only dedicating an hour once a year to prevent that. So I always tell people, if you can connect to it with quick fittings, you'll make your life easier down the road. But good question.
I do want to say that somebody sent in a question that said, in a very hard water environment, does the chemical still last 4 years on average? And we actually had somebody that uses our Eco Pro and cart answer the question in the chat and said, I've been running the same drum of chemical in Florida since 2020. It lasts as long as you don't flush with water too much / dilute it. Very hard water. So that is when Brian says the chemical lasts you a long time, it's almost too good because people don't buy it as often as we'd like. So
we often joke about taking the filter off, but no, it's been a very good product. And again, we're treating the effects of poor water, right? So you want to also attack the cause, because it's one thing to clean out, it's going to happen. And that's where the high performance coolant comes into play. You're eliminating the water, but still you need things clean, and you need good and turbulent flow. Berger and Brown and SmartFlow, they have great tools online to where you can plug in your temperature of your water, glycol, your percentage of glycol if you're running that, your line diameter, you'll find your delta T, and then there's a sweet spot. It's called your Reynolds number to hit turbulent flow, right? And so any type of buildup, and again, I mentioned earlier, 30,000s can affect cooling it by as much as 60%. It just acts as an insulating layer. So if I'm just getting laminar flow, I'm not capturing all of the heat transfer, and that's where turbulent flow comes in. It achieves two things. One, you're taking out as much heat as you can by capturing all of the surface area. But two, if you've achieved turbulent flow, you're not really giving your contaminants a chance to collect, right? Because you've got such good flow. Where it does collect are little pockets like that manifold block that I sent around. If the plug on maybe one of these circuits that you're not using isn't flush with the ID and you've got 1 or 2 threads exposed, that's a nice little sweet pocket for contaminants to kind of collect. And then obviously there's heat coming in that, and it just kind of builds and builds and builds. So, but thank you to the user that chimed in. It's been using it since 2020. That's good.
any other questions on Zoom or in person? We still have some time before lunch.
Cool. Well, again, I'll say that if people have questions outside of it, I am available, our tagline, unmatched technical support for innovative products. We have more technical managers than we do sales reps. We're very proud of the products that we support. And if we've had the pleasure of being in your shop, I hope that we've showcased that. I know I probably rambled a little bit, and if you can't tell, I get quite excited about this product and cleaning, as weird as that sounds. My wife would not agree with me that I enjoy cleaning that much, but yeah, so we're always available. Obviously, we built the backdrop to do YouTube and Zoom chats. So outside of today, if you're ever like, hey, I like this, I want to see it, I want to train my team, happy to do one-on-ones. The other products, I'd be remiss if I didn't mention it, are foaming agents and purging compounds. So if you're looking to lightweight part or decrease your cycle time, foaming agent is a great way to do it. Purge we do for resin changes, maintenance on the barrel, and we have a really nice mechanical pellet purge. We do have Dave on site today, as well as Ron Bishop. They're both of our technical managers for those products respectively. And before I sign off, I will say you can find us on YouTube. If you take a business card today, there's QR codes on all of them that'll take you straight to that channel. Please like, subscribe. If you have any feedback, right? A lot of my videos come from user feedback, right? People are like, I want to see this, or I want to see that. Like we'll take them. Like we're built to build our online catalog, and we want to help you guys. So again, thank you to Carolyn for setting this up. Thank you for all that came in attendance. Hopefully the food gets here and we can all get fed. And if you have any questions, we'll all be roaming around. We do have other vendors here. PCS is one of our distributors. We have Tuscan Equipment, as well as Wisconsin Engraving. Tuscan Equipment supplies peristaltic pumps. PCS has a lot of mold components. They have 2 reps here. And Wisconsin Engraving has, actually, I just learned about it a couple weeks ago. They've got technology for mold texturing where they can embed a QR code that is so small you can't see it with the eye. I'm not certain if you have that set up. I got the thumbs up, so they've got that set up. Definitely check them out. Please swing by as a thank you for those guys coming out and showing their support as well. So with that, if there are no more online questions, we can do in person. You guys can come up, ask me questions, but I think that about wraps it up for the Zoom chat.
All right. Thank you, everybody that came on the Zoom. I'm going to end it now. And yes, so thank you so much for joining us.